Primary School.
Now we'll continue with
Electromagnetic dynamics.
Okay, so chapter 1.
Electric field and Gaussian law.
Okay, what we learned last lesson?
So last lesson, we have learned 3 things. First is the electric force. Second is the electric field. Third is the source charge versus test charge.
Yes. Okay, and can we explain them with a few sentences?
First, which we have the electric force. It is actually the attraction, repulsion between the two charges.
What about point?
Okay, so
point 1 for sentence 2.
So actually for that is for the electric force.
Okay, point 2.
Then next we have our electric field.
Why electric field?
For electric field, well, we have the divergent for the positive charge, convergent for the negative charge.
Okay, this one is actually for the first point. What if we put 2 positive charges together?
Repel.
2 negative charge?
Repel.
1 positive, 1 negative?
Attract.
1 negative, 1 positive?
Attract.
Okay, so for this time, what we're going to talk about?
Okay, well, next we have the negative charge and positive charge, which is actually attraction.
Then I already said.
What I meant to say was the test charge versus source charge.
Okay.
So for those 2 charges, can we just change a test charge into a test region?
Okay, but first let me draw. Help me to begin.
Okay, so that will be the divergent.
So over here, explain.
So for that, well, for a positive, which is actually a divergent, and remember, it must be symmetrical.
Okay. And now.
Okay, so that is for the positive, which is a divergent, right?
Okay. Now for the negative.
So for negative, it is convergent.
Okay.
So for this, the test region, it can be like, at this part we have region 1, this part we have region 2, and then region 3. So let me just tell you a word called denser. Well, which is the densest?
First.
Are you sure?
Yes.
Which is the least dense?
Third. And let me give you a challenge. Which one more denser?
Wait. Different sizes. So actually it will be this one.
What I want to say actually, like these two same sizes except for because those are too wide. Okay, so what if these two are the same shape? This one goes through 2, this one only goes through 1.
So actually the one that goes through 2 is, I think it's less denser.
You're actually,
So is this more or is this less?
you're talking about the same. More, less. Yeah?
So here is more.
Less. Look at these two didn't overlap. Okay.
So this is actually for this. Remember, this is a region, it is no more charge.
Yeah. Actually, we can name those 4 and 5. So that means if this, like this goes up, definitely here less denser. Right?
Okay.
Because here is the nearest.
The more nearer, the
More denser. For example, you're in the source charge over here less denser, more denser, and most denser, which are actually touching it.
the denser, the stronger.
Okay.
Or you can also say the denser, the more strength.
Okay.
Which is
You
actually,
actually don't need to write those.
what is this? The field strength, right?
Okay.
And what does these lines represent?
So the lines represent the field line array. Force line array.
So those are what that represents these lines.
Yes.
And for this line, remember, for example, a positive charge over here, it is actually the electric force exerted on a
The charge.
positive test charge.
Yes.
So basically,
Depends.
this will go that way.
Wait, it won't move curvy. Okay, and if here positive charge, you will go here. And here negative charge. Here.
Yes, because like charges repel, unlike charges attract.
Yes, like repel, unlike attract.
Okay. So remember, those are called field lines or rays, or the force lines or rays.
Okay, so
So can we study what is the field structure actually like?
okay,
When we put positive and negative together, positive together, negative and negative together.
you meant by like this?
Okay, so what do you think will happen?
Okay, so these three are different graphs. This will be like okay, this is actually the middle is a straight line. Yes, the middle one don't have anywhere to go, right?
Because it's right in the middle, so I don't know where to go.
Yes.
What happened there?
Oops. Go over here. Okay. So it will be something like this, okay? Okay?
Okay, so for that positive, draw it down a little bit.
Okay. So the positive, if positive. So it's something like
So actually it will not be symmetric anymore, right?
yes. So it'll be much more like this.
Then for the other one?
You could draw the last one if you want. That's so weird. Even though it looks like a spider. Okay, so
this is how it looks like when it repels.
yes.
So see, it actually changes, right?
Yup. At first you may think that this should go here, then this go here. Totally wrong. You think that this should go here and this should go there. Totally wrong. Only like this thing correct. So let me tell you. Here I don't know where to go because that the curve already too wide. They can't go there anymore. Okay, let's first look at this picture. Why we put another positive charge here?
Well, I think it will move that way. As the force is actually applied that way, right?
Yes. Even though here also have from this. And what if we place it here?
Okay, well for that, at first it will move this way.
Yes, then when far enough from this, it will go back this negative way. Right?
Okay. So let me just tell you for this, if at this point, okay, so here is all of these electrons bigger.
Okay.
Okay, take a look at all of these and remember, this is how it actually repels.
Yes. It's like some people blow another people's hair and that people blow back the hair. Is that something like that? Like the blowing the hair.
So, can we resolve these?
Yes. And like the bigger and more like a hair growing below. now we put this part here, then it went this direction, right?
Yeah.
And since this part behind also has, because that this positive charge go to negative charge also, but if it's somewhere like over here, it will definitely first move away because this
A little bit mistake in the direction.
okay, so it'll be like that. And what if the positive charge is over here? It will likely move a bit up here.
But first, it'll move a little bit over here. First, it'll move a little bit over there, okay?
Okay, so let me give 3 points. They are all perpendicular.
Okay, so what you wanted to say is that these 3 points, you want to find out what is their,
Yes.
what is their y?
Which direction will they go?
The force direction, right?
Yes. They are all perpendicular.
So we have like this.
Yes. Faster. Okay.
Then at this part, which is actually the hard part.
So, you know wire right over there? If I drop extra one, it will follow. Yes, so it'll be like this.
Do you know why that plate is like that?
Because there's a... Yes. Okay. And why is A still facing there?
Well, this don't know where to go, so it just goes straight all the way.
That means like for example, here's the bar, and here it's just right at the end here, while the magnet right behind. Here we definitely don't know where to go, right? Because it got nothing to go. It can't have a sense. And plus it's direct at the middle.
Okay, so
This is a straight line or a curved line.
what if it is over here?
Wait, I asked you something. This should be a straight line or curved line.
This is a straight line, this is a curve.
I
For
think
a straight line, it is actually... Okay, so you want to draw that out first. So for a straight line, it's like acting... That is the force acting on a positive charge.
yes.
What do I mean?
Okay.
Okay, for example, there's a force, right? There's a positive
Yes.
charge. It goes that way.
And what is the positive charge over here?
Okay, where is the line?
For example, the line.
Okay, well, of course it will go that way, because therefore this straight line is for the positive charge. Remember, this is actually from a positive charge.
Okay, but now the question comes in, why is it in a curve?
Okay, so if it is in a curve, well, then we'll have to get the tangential.
Yes, which is also the tangent line. The tangent line shows that and where would it go?
But which direction?
Oh,
We'll have to follow the field force.
yes, the force.
Or the field strength.
Yep, it's the strength of the field that, for example, like pull the.
Let me just tell you, it is actually these. This is their force.
Yes. So that means if you put the positive charge there, the positive charge could move at the force to the negative charge.
It does not move at the force. It is, okay, they have the force that brings them together because unlike charges, they attract. But remember, for negative, it is the convergent.
And positive is a divergent.
So for this, you'll see that it is actually pointing that way.
Yes.
So for these, okay, you know that these are tangentials.
Yeah.
And remember for this,
No pointing edge.
well, you know, so we have a force. For example, here I put a positive Q1.
Okay.
And here is a positive Q2. Okay, if we hold it there at first, after that we release at the same time, which will have a greater acceleration.
Q1 of course, because Q1 further. I mean nearer. Q2 is further.
Okay, what if you just say it in force? Q1 has a greater what kind of force?
Greater in resultant force.
Yes, resultant force. So now I don't need to continue writing that.
It's a resultant, not result force.
Yes. So remember for that, it is a greater resultant force.
Okay.
Actually, for these lines, these force, who created these force? Who generated these force? Who produced these force?
So it's the charges.
Both of them, right?
Yes.
Which is the resultant.
Yep.
For these together, we can call them resultant, okay?
Yeah.
So for this, do you have any more questions on this?
No. And what you want to say?
Okay, so just the final thing. Remember, acceleration, it is that how faster it gets every time.
Yes, and what you want to say?
Okay, so if you like our videos, don't forget to subscribe to our channel.
Okay.
So we'll see you in the next lesson. Thank you for your watching.